Hello, my name is Astrid Ross. I am a special education student at WGU. I'm giving a presentation for my Application of Effective Communications course. Here it goes. Research suggests that when teaching very young children math skills and concepts, it is best to use hands-on materials and manipulatives to teach about concrete concepts. Mathematics is a combination of concrete and abstract understandings of the world. Manipulatives provide students with tactile experiences to help them model, describe, and explore. In education, math manipulatives are concrete materials used to introduce skills and development of concepts of understanding. Manipulatives can be in the form of flashcards, spinners, pattern blocks, counters, dice, craft or popsicle sticks, or many found or homemade materials. Math manipulatives are all an important and significant component in teaching early math skills and concepts to elementary children. Children need to have multiple and complex educational experiences of both the concrete and the abstract to gain mastery of the world around them. Children have very little understanding of abstract ideas and concepts, but can readily grasp and manipulate and comprehend what's put in their hands. Children learn mostly through play, investigation, and exploration, and interacting with the world around them. Research asserts that children have varying levels of development and growth. These levels of growth that mature and scaffold, and levels of depth and complexity. At different developmental stages, the young child needs varying educational experiences to continue to grow. The type of experiences that should be introduced to children depend on where they are in their stages of development in physical and motor skills, social and emotional development, communications, language and literacy, and cognitive development. The Georgia Department of Early Care and Learning uses a set of early learning standards that are based on this research. Beginning at birth, children interact with the world around them through their senses. As babies mature, they continue to explore the world through their sense of touch, taste, smell, and hearing. Play is natural exploration and investigation. Tools like blocks and balls become understandings and develop the young math mind. Concepts like object permanence and one-to-one correspondence begin to develop into higher and critical thinking skills and levels of pattern recognition, quantity, and spatial development. In 2002, Patricia Moyer wrote in the Kluwer academic publisher about a research study using the finding of several math teachers incorporating math manipulatives into their direct instruction. They used varying materials such as base 10 blocks, color tiles, snap cubes, geoboards, dice, pattern blocks, 100 boards, fraction bars, tanagrams, rocker scales, thermometers, centimeters, and inch tapes. Their experiment concluded that their materials brought life to the lesson, was fun for the students, and brought a deeper understanding of math. In 2010, in the Journal of Educational Pedagogies, Matthew Bogan, Sally Harper, and Anna Whitmire wrote to explain the importance of the significance of using math manipulatives as tools to teach. Since ancient times, people of several different civilizations have used physical objects to help them solve everyday math problems. History has shown that as far back as early Mesopotamia, Egyptian cultures, Greek and Chinese cultures have used versions of an abacus, counting boards, and sand trays to complete accounting, calculations, and early computation. This abacus that was used has evolved over different cultures and through many generations to be used for mathematical representation. This particular math manipulative can be used in many ways and to represent multiple math concepts. This is an abacus. A child can learn to represent numbers, for example. Take the number 10. On the first row of the abacus, we can use the counters to represent the number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can also go past that base number 10 to represent numbers on a larger scale. Take the number 15. We've completed the 10 at the top, and we'll add 5 more. 11, 12, 13, 14, 15. So we've shown a one-to-one correspondence. We gave a representation of a physical visual of a number, and we completed an addition problem. So let's do something else. Let's try a subtraction problem. Let's take 15, take away 3. So we have our 10 plus 5, which is 15. Now we're going to take away 3, or subtract 3. 15, 14, 13, 12. Now we've shown students from a real-world application through a visual of tangible, hands-on, what a subtraction problem looks like using an abacus. And there are many other applications and math problems that can be completed using an abacus. A child can learn about patterns, multiplication, and many other math concepts and skills. This one manipulative can be used as a tool of concrete representation and in helping to build many foundations of learning. Thank you so much for watching my presentation. Have a good day.